be showing you machine tool verification in NX CAM. My name is Candace Burrell, and I handle the marketing here at Swoosh Technologies. Feel free to submit any questions through your GoToWebinar panel, and we'll address them at the end of today's session. So I'd like to introduce Matt Beisel, first of all, who is an application engineer and CAM instructor here at Swoosh. Now, Matt will walk you through some of the machine tool verification functions in NX CAM, why it's used, and why your company should utilize these great capabilities. So go ahead and get started, Matt.
Okay, Candace. Here we go. Here's the agenda. First, we'll talk about what is machine tool verification, why do we want to use it, how does this work in NX. We will then show a live demo of machine tool verification in action, followed by why you should use NX verification, and then I'll also show you resources and contact information. So what is machine tool verification? NX NC Simulation provides a complete simulation environment for simulating today's complex machines. The simulation in NX you get is real. What I mean by this, it is a G-code simulation. NX simulates the same code that is sent out to the machine, so the simulation results are based on real-world conditions. Some other simulations with other CAM softwares are not real and use simulations that are not based on G-code. So the results that you see with these other systems are nothing more than watching a video game. They're not real. With NX CAM simulation, you can accurately simulate gouges, collisions, and cycle times. So why do we want to use it? You can verify machine tool programs offline, not tying up valuable machine time, operator time, and programmer time. You can prevent collisions to the machine tool. A spindle replacement can be very expensive, or any other damage to your machine can be expensive. Also, you can prevent gouges to your valuable parts. For example, you could have a $6,000 casting and want to prove out a new program on this part. Proving it out virtually prevents you from scrapping this casting. You can give the program the extra confidence he needs when getting ready to prove out or hand over a program to a setup machinist. And also, you can test advanced machine tool functionality. Today's machine tools have advanced functionality that you need time to test out. It is often difficult to get time on the machine away from productions to try out your machine's advanced functionality or performing R&D. Now if you have a simulation and laptop, you can go ahead and simulate the machine from the comfort of your own home. So what do we need to use this? You need the software. So NX CAM 5-axis machining, NX Total Machining, or NX Advanced 5-axis machining, or the NX NC simulation add-on. You also need a machine model and CSE files. So what kind of machine model do I need, and what are these CSE files? As far as the machine model, any solid model assembly will do. It is suggested that when you purchase your machine that you specify in your purchase that you'll need a model as well. The CSE files. CSE files contain multiple components. Basically, you have something that will identify the G-code, a way that your kinematic model is created with your solid model of your machine, a control file that will tell the machine what to do, so a G-code such as G0, G1, rapid, linear, cycles, M-codes, etc. And then also your machine-specific file. So this will have your acceleration, deceleration in that file, so you can get accurate simulation times. So how do I go ahead and use this in NX? So in NX for manufacturing, you're going to go ahead and program your part as usual. Then what you'll do is you'll go to the Machine Tool Navigator or the Operation Navigator, and then have the option to choose from a variety of machines. And I'll go ahead and show you the steps to go ahead and do this a little bit later here. So as far as the variety of machines that were shown on the previous slide, There are 16 out-of-the-box machine simulations, each with FANUC, Sinumeric, and Heidenhain controls. They are either in inch or metric. There is also an Akuma Think controller as well. So the types of machines that are supported and that are shown in the out-of-the-box examples are mill turn machines, milling machines, turning machines, and something they classify as a turn mill machine. They also have a gantry type 5-axis machine that shows head changes. And each one of these machine simulations comes with a post processor. Can you hear me, Candace? Okay, good. Okay, so what I'm going to do is I'm going to go ahead and show a simulation here in NX. So what I have here open is a turn mill simulation. Okay, so this is a turn mill machine with a main spindle, a sub spindle, upper turret, and a lower turret. So the reason that I'm showing this is to show the complexity of machines that NX simulation can go ahead and simulate. Okay, so the type of machine that we're going to simulate here it is fairly complex. And so what we have here is we have our G-code output. And we have two channels. So we have one channel driving the upper turret and one channel driving this lower turret with synchronization code. So this is a real simulation. So as you can see, you know, things wiggling around here. You can see that it's switching channels. So like if you guys are familiar with this stuff, this is kind of high-end stuff for doing verification. Maybe only one other verification software is capable of doing this type of stuff. Okay, so what we have, it did some turning on the lower turret, and now it's going to do some pinch turning here, or final turning actually, with the upper and lower turret. So just wanted to go ahead and show you that. Okay. The next thing I want to go ahead and show you is an aerospace type component. Okay, so let me show you how easy it is to go ahead and use this simulation. So I'm going to go ahead and select my impeller, this part that we have programmed, and right now it's not specified to a specific machine. So what I do is I just go to the machine tool view, and this is NX 9.01, and this is what it looks like. So you guys might not be familiar with it if you guys haven't downloaded it. So I go to the machine tool view, and then I just go in and select the type of milling machine that I want. And since this is probably needs to be cut with a 5-axis machine, I'm going to go ahead and select a 5-axis machine here. So I can go ahead and select any of these. Let's go ahead and try this one here. Okay. So I pick the machine, and the next thing I need to do is say, okay, I need to put this thing on the machine, so where am I going to put it? So I'm going to go ahead and plop this down on the machine, and I'm just going to leave the way the settings are there. And since I didn't mount it to the base, it's kind of floating, and I don't have the fixture showing. So just imagine there's a fixture there. Okay, so now what we go ahead and do is we have our machine, we have our part, we have our program, and we can go ahead and simulate. So I select the NC program, click on Simulate Machine, and what you'll see is the simulation interface. Okay, so what I'm concerned with is what's in this window here. So I'm going to single step the same way that I'd go ahead and single step proving out a program out on the control. Okay, so we're tilted up, and I'm going to zoom in here, and we're going to go ahead and see what's happening. So we're going to watch this this thing kind of wiggle around here. Okay, so it's fairly complex motion. Okay, and if you look at the code that I'm going through, what it's doing is it's posting out, one line at a time. So it has your preparatory codes, all these different codes, and we can go ahead and single step through it forwards or backwards. And then we have some, other simulation settings here. So we can go ahead and show 3D material removal. I'll show you that on another part. We can show the tool path and tool trace, and we can also, analyze the thickness. And we'll look at that in a minute. Right now, I just want to go ahead and show you the tool trace. And so what this is going to do, it's going to just draw the linear motions of your tool path. And it looks like I have to go ahead and reset it. I'll go ahead and run this again. So you can kind of see the blue line. So red is rapid. It's feeding around here. And so we're able to go ahead and simulate, and this is actual G-code. So what it's doing, it's simulating the code line by line, just like your controller would do. Okay, it's not an internal simulation. So right here we have machine code simulate. So this is a machine code simulation. If we were like, did like the competitors do, we would have it to toolpath simulate. Now if I go ahead and single step through this is the internal representation, but it's not the actual G-code. Okay, so that's just kind of the difference. So one method that other guys use is internal. We can do that too, but also we can have a G-code based simulation. So this is an aerospace part. Okay, the next part that I want to go ahead and show you is a mold and die part. So I'm going to go ahead and open this mold and die part that I was playing around with. Okay, so we have the part programmed, as usual. So the next thing I'm going to do is I'm going to go ahead and select my machine. Go in, select my machine. I can select like a 3-axis milling machine or a 5-axis. So each one of those machines has units, so millimeters or inches, and the type of control. So FANUC, Cinemeric, Heidenhain. I'll just go ahead and select FANUC. Okay, and now what I'm going to do is I can use the part mount junction or use assembly mating. I'm going to use the part mount junction because it's just like a coordinate system that's anchored in space that assists in placing the part. So what I'm going to do is I will go ahead and specify that. So I need to go ahead and position it in the specific location that I want. Okay, and then what I need to do is I just need to rotate these. And so if you guys are new to NX, it's really easy to reposition like vectors and stuff. So I've got X going this way, Y going this way, and Z's going out, so that works. And so this is how it mounts the table. So like as a real machine tool, you need to tell the operator you have to know where you're going to go ahead and put it out on the table. So that's what I just did there. Say OK, OK, and boom, I'm ready to go. Okay. So now what I'm going to go ahead and show you is we can go ahead and show 3D material removal. So this is a 3-axis mill with a tool changer. This will go ahead and simulate the tool changes. Let's go ahead and see what that looks like. So I'm going to simulate the machine. I have it set on machine code simulate, which is the one that's going to actually simulate our G code. And now I'm going to single step through our program. Okay, we got our tool change. Okay, and we're going in here. And so we can go ahead and see this, 3-axis simulation. Okay, so what I have, set in my simulation settings is I have it to go ahead and pause. Well, I guess I don't have it. Pause on collision detection. So if I have this on, it's going to watch out for collision detection. So if the machine gets whacked, if the shank of the tool hits the side of the part, or the tool hits the table or the fixture or the machine, it's going to let me know. Okay? So I'll just go ahead and continue to simulate. And it's not so exciting here, so let's see if we can make it maybe a little bit more exciting. Okay? So we went ahead and looked at the simulation here. And the next thing I'm going to do is I'm going to reset our simulation, and I'm going to show 3D material removal. Okay, so now I've got my block, and you can kind of see the surface. It looks like broken glass. It's where the face of the solid and the face of the part are kind of in the same space. Okay, so now I'm going to go ahead and simulate here, and let's go ahead and see what happens. Okay, so I am removing material. So this is the way it would look out on the real machine. Okay, and this, it looks like this example has shallow depth of cut for high-speed machining. So what I am going to do is I'm going to be as patient as possible, but I think I'm going to stop it here in 1 second. Okay, so if you're familiar with NX, NX has ways to go ahead and compare the part. So I can go ahead and analyze what's been cut. I can go ahead and check to see how much thickness is on the stock, to see if it's removed the amount of material that I want. So one way that I can do that is I can click on Analyze, and I can click on that, and I would be able to click on any point in here. Then I can also show thickness by color. And so this shows a visual representation of how much material is left on the part. Okay, so what you'll see is these different shading values, and I can go ahead and change it. So I could say, okay, this color I want to show 10 thousandths, this one I want to show 5, this is 2, this is 1. So we can go ahead and change the shading, but this shows where there's extra material or where there's deficient material. So you can determine if you're in a material positive or material negative condition from your simulation. And so you can avoid, that material negative position, condition that would go ahead and scrap your part. Okay, so that was a 3-axis mill. So I am going to go ahead and show you one more here. Okay, so I'm going to go ahead and show you a medical part. So I'll go ahead and close this guy here. And I'll see if I can find my medical part. Okay. So this is a knee implant. This is a knee joint. So what I'm going to do is I'm going to go in and select my machine. I'm going to go ahead and select a mill. Okay, and so each of these, is real post-process or real NC code. Okay, so it's just like I'm taking this part and I'm plopping it on another machine. So I've decided I've got this part and I want to go ahead and cut it on like a 5-axis table. So let's see what that looks like. Okay, I'm going to go ahead and specify my part mount junction. And I want it to be stuck on the table here, so I just have that. That looks like it kind of works for me, so I'll say OK. Okay, so I've got this thing on the table here, and now I am going to simulate what we have. Okay, so this is kind of a big program. So what I'm going to go ahead and simulate is this finished bearing surface. So the bearing surface, they call it, is this curved surface that's kind of this green area that's right here. So if you guys can see that, kind of. Okay, so we're going to have to use 5-axis, so it's a good thing that I picked the 5-axis machine. So now I'm going to do machine simulate. Okay, and on this one I'm going to show my tool trace because I want to see where it's going. And I'm just going to make sure machine code simulate is set. And another thing that I can do is I can show the machine axis positions, okay, and then in the future they plan on having all the modal stuff that you would actually see on your control. So this shows like the actual machine axis positions as we're going through the program. So I'm going to go ahead and single step through this. Okay, and it looks like it just made a tool change, so it went in there, snagged the tool, and in these demos I've been selecting FANUC code because it's what I understand the most, but we do have Cinemeric and Heidenhain. So now we're going in. Okay, so everything so far so good. Okay, so it looks like it shows that this fixture turned red because the clearance value from this and the tool, it's too close. So I have it set too close. So if your tool gets too close to your fixture, it's going to go ahead and warn you, okay? So the way I run my shop, it's only going to cut this fixture. It's only going to crash into the fixture once because it's going to remove the material that I don't want that's on the fixture, so that works for me. So I'm just going to continue on. Okay. So you can see we're simulating this fairly complex motion. And it's just, flying through the NC code. So with this, I can prevent gouges. I can prevent damage to the part. I can get a real idea of what's going to happen. And also I can get accurate cycle times. And, playing around with the machine, I'll be able to play around with the machine, without taking it from valuable production time. Okay, so that's kind of what I wanted to show you guys. So I'll go ahead and stop, and let's go back to our PowerPoint here.
So why choose NX for your verification needs? It's very easy to use. It's based on proven technology. It's an integrated solution, and it has advanced technology. NX simulation is very easy to use. It's easy to set up your simulation environment with your 3D tools, your devices, and fixtures. NX NC simulation is based on proven technology of RealNC in the Technomatics product line. And this product's been around since 2002, and then it was acquired by Siemens in 2005. So there are thousands of machines in use using this simulation technology. And you might not have heard of RealNC in the past, but it's very popular in Europe and Asia. NX-NC simulation will help you eliminate extra steps in the process. So exporting your NC code to a separate verification software, you won't have to do that because it's one integrated product. You can go ahead and keep your data organized, so you don't have like a separate file in a separate system that you have to go ahead and keep track of multiple files.
Also, this is easier to maintain for your IT department. So they're administering one system and only working with one vendor. And also, you're going to have reduced training costs due to, our easy-to-learn, consistent user interface. So CAD and CAM look similar, and so does simulation. So in the long run, this is going to go ahead and pay off for you. NX NC Simulation uses advanced technology. So you can go ahead and simulate a multi-channel machine. So if you have a multi-channel machine, you have a separate program running on your main spindle and another part being cut on your sub-spindle, or multiple turrets. So NX Simulation goes ahead and supports that. And it also has something fancy for Cinemeric controllers that's called VNCK. So what you have for your Cinemeric controllers is you can actually emulate the actual hardware that's out on the floor. So it's exactly like having access to your machine control, but it's a little box that plugs into your machine, and it's a virtual controller. So it'll act exactly like your machine would on the floor. And then also with the Siemens controllers, you can use this VNCK technology, and then you can also take a look at the control. So you would be able to see the simulation of the machine, but actually what it looks like, the control interface as you're operating it on the machine. So now that you know about machine simulation, where do you go from here? So one thing you want to do is find out if you have the add-on or if it's in your license. So you can go ahead and contact Swoosh for this if you're one of our customers, and if you're not, we can point you in the right direction. You can find an out-of-the-box example that most closely matches your machine. And I went ahead and showed you where this folder is. Candace will be sending out a replay so you can go ahead and check that location out. And then go ahead and start experimenting. If one of the out-of-the-box examples doesn't work for you, Swoosh can customize it to your needs. Things that we'll need for this is a machine model file, controller manual, and or cycle controller requirements. Thanks for taking the time to learn about NX simulation, and I will talk to you later. Thanks.
Thanks, Matt. I just want to leave a note that you guys, if you have any further questions, go ahead and you can contact us with the contact information on your screen. We'll also leave you some with some follow-up information. You can respond to any of the follow-up emails as well. We do have a couple questions that came in, Matt, if we want to go ahead and address those real quick. The first one is, can you simulate your own G-code?
Yes, you can go ahead and simulate your own G-code. So let me go ahead and show you guys that real quick. Like one of our examples here, so we were just looking at this finished bearing surface. So each one of the simulation files has a post and simulation and kinematic models, all that fancy stuff. So what I want to do is I want to post this out externally. So I'm going to post-process like I normally would in NX, and I'm going to figure out where I'm going to dump this. So I'm going to dump it on my desktop, and I'll just name it something here. Say OK. Okay, so it's going to be posting the post processor that's matched to our simulation that we have. So say OK. And maybe I picked a fancy toolpath, but we can be patient here.
And I do want to go ahead and remind everybody that
what it's doing, it's checking for
NX
collision and all
training.
that stuff.
So we do NX training, we do customized training.
So
You
in
can
a
go to our
couple
website.
seconds, we'll have our code pop up. Okay, so it's a lot of lines of code. So this many lines of code, if I handed this over to an operator, he said, that's crazy, but that's okay, because I'm not going to be at the machine. Okay, So I've got that there. Got my code. So now the next thing, so you could have an old program and just go ahead and simulate it. So I'm going to go ahead and load that program that I just posted out. Okay, so we saw what Simulate Machine does. We have this simulate machine code file. Okay, so it's asking me for some code that I want to go ahead and use. So this is the code that I just went ahead and posted it out. I'm going to say OK, OK. And so now it's reading that file that I have. So I'm going to go ahead and single step it. And it's asking, you know, for a block of material. Let's see. I'll say OK. I'm going to single set. It's doing the tool change. And then hopefully we get kind of the same type of motion that we got before, and we do. Okay? So you can also use this, you know, externally. So you just have the G code. So if you want to go ahead and see what old programs are doing, you can load these old programs. Okay? So I hope that answered your question.
Great. And we also have one more question that came through. Where can I learn how to build my own machine?
Okay, building your own machine is, you know, a fairly involved process, so I wouldn't recommend to really learn how to do it, you know, unless you build like 8 or more machines a year. There's a lot of knowledge, you know, that comes with learning how to do it. And, you know, some people, you know, at most shops are too busy, you know, to spend a month or two to figure out how to use this stuff. So you can build your own machines, and like on the Siemens website, there is some detailed information. Swish, this is one of the services we offer. We offer machine simulations and post-processors. So we have people here that are dedicated to doing that. So as far as the information, if you kind of want to start out on your own to learn about this stuff, there's a website, and it's the NX Manufacturing Forum. Let's see. And so this is the NX Manufacturing Forum that we have, and what it has in here, if you dig around in here, it has some instructional videos, and it probably has maybe 2 or 3 days of showing in gruesome detail on how to build these machines. So, you know, it's not for the faint of heart. It's pretty hardcore stuff. But the information's there if you want to use it.
Great, and I do want to just remind everybody, you can head to our website at www.suschtech.com. View our training schedule. If you need a customized class, we can do that for you. If you need just mentoring, maybe on a post-processing or something in that nature, just, you know, let us know, give us a call, send us an email, and we'll definitely make sure we can meet your needs and your requirements. Thank you all for joining us. Thank you, Matt, for giving us such a great demo. Have a good day.